Hi there. Welcome to Mr. Lewis Speed Runs Your Homework. So I'm going to be going through your homework. The first one I'm going to be looking at is problem set 1.3, graphing. And the point of this is not for me to just do homework quickly. It is just as a demonstration how to do the homework. So that way we're like maybe help clear up some questions that you might have. So let's go through it real quick. So here's what the assignment will look like. And again, this is the first one, problem set 1.3. So we're going on a car, 30 minutes, check the odometer, record the distance every 30 minutes. Okay. So real quick, our elapsed time, that's coming first. So that's going to be our independent variable, which goes on the x-axis, because x-axis always comes first. Then our y-axis, what we're measuring as an outcome. So every 30 minutes, we look and measure the distance. That becomes the dependent variable because that's a measurement. So dependent variable is distance traveled, which goes on the y-axis. Okay. Next thing, we got to make an Excel graph. So go ahead, open up Excel, open up the desktop app version because that's the better version. The other ones are not very good. Remember, x-axis goes first, then your y-axis second. The x-axis is your independent variable, which in this case is time measured in minutes. And our dependent variable, which is the y-axis, is distance measured in kilometers. Okay, so we need to recreate this data table over here. So we're going to start with 30 and just keep adding 30 until you get to 240, I suppose. One too far. Okay, so 30 through 240, you can just type those in. I'm just trying to save time. 35, 62, 92, 122, 152, 181, 211, 242. Cool. So we got this, and we need to make a table out of, or a graph out of this. So I'm going to highlight this, click Insert, go to Charts, go here, Scatter Chart, Scatter Plot, the best one. So we have our axes, we need axis titles, we have a chart title, we need a trend line. The only thing about the trend line is it doesn't tell us a whole lot unless we have an equation. So we need to click this arrow, more options, the second from the bottom, display equation. There we go, got our equation. Very important that we get our equation. Make sure your title is your independent variable versus your dependent variable. So independent was time versus dependent variable, which is distance. Label your axes, time, minutes, distance measured in kilometers. Okay, so there we go. This graph is forming an upward sloping line as time decreases. So if we, like for example, we went from 200 to 150, going to the left, the distance is decreasing as well. What is the slope of the line? Okay, 0.9885. So I'm going to write 0.989, rounding off to that third digit. What is the y-intercept? Mine is 3.68, measuring off to that third digit, 6, 7, 8. Okay, so the basic equation for a line is y equals mx plus b. In this case, y is travel distance, which we call d, and x is elapsed time, which we call t. So basically just swap d, or swap y for d, because y is measuring distance, and swap x for a little t, because x is measuring time. We found the values of the slope m and b, so rewrite the equation. Okay, so instead of y, we're going to write d for distance, and then we need the slope, which is 0.989. Instead of x, we're going to write time plus our intercept, which is 3.68, those are my numbers, your numbers will be different. So the reason we do that is that way we can say, okay, let's input this new time in this equation, and that will give us a new distance. Okay, so I'm going to take a calculator, and I'm going to say, okay, 0.989 times 200 minutes, because that's my new time, is equal to plus 3.68, 201.48, so I'm going to round that to 201. How much time would it take the car to travel 220 kilometers? Okay, so just a little bit of algebra I can show you. Okay, so what's our equation here? Cool. Right. So we have equations. Okay. Our equation is d equals 0.989 plus 3.68. Okay. We need to solve this for distance. We are given a distance of 220 kilometers. But, oh, I forgot time here. But we don't know the time. So, if we plug in our number, plug this number in there, that would give us the equation. 220 kilometers is equal to 0.989 t plus 3.68. We need to get t by itself. That is our goal here. So to get t by itself, first we need to get rid of this 3.68. So we'll do the opposite operation. Subtract 3.68 from both sides. And let me get rid of that unit because that's just kind of complicating. Well, yeah, it's complicating things. I don't have time to explain why 3.68 is also in kilometers. Okay, subtract that from both sides. That cancels these. 220 minus 3.68. So 216.32. Now this is an intermediate answer. We haven't figured out the whole problem yet, so I'm not rounding until the final answer. So 0.989 t. Okay. Now these two are being multiplied. To get t by itself, we have to do the opposite function. If it's multiplying here, we're going to do the opposite, which is division. So divide both sides by 0.989. So divide this by 0.989 to 18.72. So that gives me t equals 218.72. Rounding with my sig figs, we have 1, 2, 3 sig figs, so I got to cut this off, round up into that. So that will leave me with 219 minutes is equal to time. So here, put 219. Oh, I didn't put units. Oh my goodness. There we go. Boom.